All right, the wheels got themselves mounted and balanced today. So that part's all taken care of. Now, one thing we didn't talk about that is very important that we have not done yet and absolutely needs to be done because we had the whole front suspension apart, the whole rear suspension apart, put all new bushings and spherical bearings and all kinds of other goodies in it. And basically the camber and castor settings we just set in the middle of the adjustment and adjusted the toe with a tape measure so that it was a 1/16 to an 1/8 of total toe in. So that's pretty simple to do. I mean, I've done that, been doing that for decades. I mean, if you just got to set the toe, it's super easy. You measure across the front of the tire, and then you measure across the rear of the tire. When you got it right, the rear measurement should be a 1/16 to an 1/8 inch longer than the front. So that's not a big deal. What is a big deal is camber, which you can do a couple different ways. The easiest way is to put something, well, first put the car on a level surface, which we've already checked with this level and this gauge on it. And it is, the floor is very, very, very slightly pitched this way. So, I mean, it's less than, it's probably about 1/10 of a degree. So that's pretty easy to, we're probably not going to be able to adjust it that accurately, so we're not going to worry about it a whole lot. We'll take it into account though. So what you do is you assume that this wheel is in good condition and it is straight, it's not bent. So this is what we propose to do to measure the castor, the camber, and the castor too. We'll get to that later. Basically, you make sure you don't get to any lumpy part on the tire. Make sure this is level, and then you press it up against it, making sure it's flat. Then put your angle gauge there. And we're at about -2 degrees of camber. That's kind of a lot. Then just to double check yourself, do the same thing here and on the back side. You don't want to get in the middle here because the tires kind of bulged out a little bit just because the weight of the car is on it. So I like to go in the rear third and the front third of the wheel. And we've got right about 2 degrees again. I already measured the other side and that was right about 2 degrees. So we've got a bit too much negative camber. The adjustment is in on the shock. And that's fairly easy to do. The only difficult part is the wheel is in the way in the tire. So what you have to do is jack it up, pull the wheel and tire off, make an adjustment that you think is the right direction, put the wheel and tire back on, and roll the car back and forth a bunch, and then check it again. You know, you roll the car back and forth to get it to settle down after being, you know, expanded. And you just do that until you get it right. We're shooting for about a 1/4 degree negative camber, or slightly less. The next thing is more difficult to understand, but the way you measure it is basically the same way. except you have to measure the camber at two different steering angles, plus 20 degrees and minus 20 degrees. You take those two readings, camber readings in degrees, add them together, then multiply them by 1.5, and that will give you your Castor angle. Now, what we're probably going to end up doing here is, I've seen one guy do it this way and it seemed like a really good idea. Basically, he took his wheel and took something very much like this level here, set it on its side, just drew with a Sharpie a straight line, then he put a protractor on it and marked out 20 degrees to the right and 20 degrees to the left. Then he steered the steering wheel so it was at 20 degrees that way, measured the camber, steered it back, measured the camber again at the other 20 degree mark. So that's how we're gonna do it. Here's this is my old control arm here. I figured I'd show you the camber adjustment since we can demonstrate it a bit here. So this is the left side one, so basically it's the one that goes on this side. And what you have to do is, to adjust it, is get in here and loosen this nut, and then you'll be able to move this. If you look under the car, you'll see this little tab sticking down. Actually, if you look under the car right now, let's see it. Should be right in front of that shiny aluminum thing. Right there. Wait. Yeah, right in here is where it is. So, if you look down on it, you can see what happens when you move this back and forth. That's to the left, that's to the right, that's to the left, that's to the right. So you can see when you move this that way to the left, the ball joint moves forward. And when you turn it to the right, it pulls the ball joint back. And that moves, I mean, this is the ball joint, so the strut sits right on here. So you're moving the bottom of the strut back and forth, which changes the, you can imagine the Castor angle being a vertical line and it's moving either that way or that way, as opposed to camber, which is the wheel moving angle this way or that way. So that's the project for this weekend. I realized I don't have a protractor, so I was just rooting through the house trying to find one, and I didn't find one, but I have carpenter's square here that has an angle scale on it. The only problem with that is these are meant to measure angles from this pivot point and go like that. So that means we're going to have to make something to clamp to the wheel and move this thing out a little bit, maybe with a piece of wood or something, so we can actually use it. But that's the plan. And this is just the front. We still have to do the back. The back, I have no idea. I never even checked the toe. So before we put those nice pretty wheels and tires on it, we're going to get this stuff adjusted and do some wear checking on these tires, since we put, I don't know, 1,000 miles on them maybe. And we know it's not right. I mean, so far we know that the toe is probably right about right. The camber is -2 degrees on both sides, which is way too much. And I have no idea what the caster is yet because I didn't check it yet. So that's the project for this weekend. Alright, so we have our initial alignment results here. I was able to figure out how to measure the camber and the caster using level, a yardstick, a angle measuring gadget. It's actually magnetic, so if this was metal you could just stick it right to it, but it's a plastic level, so that doesn't work. A carpenter's square to measure the angles using the pivot. Using the pivot point on it, and I used this pick to pivot it on, and a 2x4. And so here's what it looks like when you do it. Let me get this out of the way. I just put the yardstick on there so I could elongate the line when I turn the wheel 20 degrees. Let's see if we can manage to do this with my foot. So that's what you have. You have your straight line for when the wheels are straight. Then you have 20 degrees this way and 20 degrees that way. And this is what we came up with. Like we said before, we have -2 camber on the left, -2 camber on the right. And I measured the height right at the center of the wheel to the body on the fender there. And the left here was 25 inches, the right was 25 1/4. You know, you can't really, the body's not very accurate, so it's not really the right way to measure height, but you do it off a suspension mounting point, but we can't really get there in this car too easily. So this is what we came up with for caster. Caster 1 was -1.5 degrees, and caster 2 on the left was 0.5 degrees, which was -2 degrees times 1.5 equals a total of -3 degrees negative. I think it's negative caster. I'm gonna have to look into that. I forget if it's supposed to be negative or positive, but we'll look into that some more. And on the right side, we got our caster 1 was -2 degrees. Our caster 2 was -0.05 degrees, which was -2.5 degrees. Times 1.5 is -3.75 degrees. So, yeah. Now I have to figure out if that's right or not. That's actually pretty light. I think it's supposed to be about 6. But yeah, let's look in the notebook here real quick. What's the notebook say? Brake braid, alignment, front toe 1/16 of an inch in, camber -0.5, caster, steering angle 20 and 20. Caster should be about 6 degrees. So okay, so we are overboard on negative camber because it should be about -0.5 degrees, and we have -2 degrees on both sides. And on caster, we've got -3 on one side and -3.75 on the other side, and it's supposed to be, I guess, -6. I'll have to figure out which way we're supposed to go, but I'm pretty sure it is minus. I'm pretty sure we're right. So yeah, we got some adjusting to do. What we're talking about here is, first thing you have to do is remove the brake duct, which bolts right on the strut here. And this bolt here is actually the camber adjustment. If I can get get around the light here. These two bolts are what bolt the strut to the hub assembly. This is just a straight through hole. This one has this eccentric on it. There's an eccentric on the other end of it, and this is just a washer with an eccentric on it, and the bolt has a flat on it to drive this washer around. So grab the right wrench here and we'll move it a little bit so you can see what's going on. Hard to tell if that's enough or not, but yeah, you got it. Now, I put this gauge out here so I can see what's going on. You got to move it pretty far to get it to go. I also have this screwdriver stuck in the top to force it, you know, the weight's going to be on it, so you want to kind of get it pushed that way to, you know, for when it's settled, because it's going to want to settle that way anyhow. And really right now I'm trying to get to like about 0.5 degrees to the right of that 90. So let's see if we can do this one-handed here. Hey, it don't look so bad. Maybe a shade more. Yeah, I'm liking it. Well, I'll look at it in the camera later. That'll be easier to see. But so that's the camber adjustment. Toe adjustment, it's a typical rack and pinion steering, so you've got threaded steering rods here, and these are the tie rod ends. You know, lock nut. You loosen the lock nut, spin this some, and you know, that's how you adjust the toe. Castor, a little more complicated. So this is a Castor block. So you've got this what looks like a bolt that goes through, but it doesn't. There's a nut here and a nut here. In the middle, these two shafts are eccentric to each other. So as you turn this tab here is actually attached to the what the nuts are attached to. So as you move this back and forth, you change the caster angle. Kind of like we described before with the control arm on the floor, but you gotta loosen that nut and that nut, grab this with a vice grip, and turn it the way you want it. And that's pretty much how you do the front. This bolt here is eccentric, so I have this wrench on it now. I don't think I could turn it. Well, I could probably turn it a little bit, but that will move this aluminum piece up and down relative to the spring plate. This is the toe adjustment. Now they make a toe tool, which is basically a hex-headed, you know, stud that fits this round hole, and it has a smaller stud coming out the back of it that is offset, so it's eccentric, like all these adjustments are in this car, and it fits into that slot, which is part of the spring plate, if you can see it through the hole there. So as you would turn that, it would move this aluminum piece forward or backward relative to the spring plate. And that, if you look down at it, is going to either give you toe in or toe out. So right now we have 5/32 of toe in. So we need this to come back this way a little bit. And we have like 1.5 degrees, I think it is, of camber. So we have to make an adjustment on this. The trick here is that both of these adjustments slide this aluminum piece on the spring plate. So to adjust either one of them, you have to have these 3 bolts loose. So it's that's why they make the toe tool. If you put the toe tool in there and you turn it to a certain spot, it'll stay there while you're making the camber adjustment. Okay, so we made our adjustments. I ended up making a mark around the aluminum trailing arm. You can kind of see the outer one. I don't know if you can see that, but this aluminum trailing arm is further back that way than it used to be, which is basically, I used, not that big screwdriver, little pry bar, and just went in there like this, put this end against the aluminum trailing arm and stuck this in a little further against the spring plate and pried them like that to get it to move. Now I used my gauge again, and it looks like we got a little bit less negative camber. I don't think it's a whole lot less, but next thing to do is put it back on the ground. This is all tightened up now. Put it back on down on the ground. We'll take it out for a ride and see what it feels like, then bring it back in and make some measurements. Alrighty, so we're about done with our Hillbilly four-wheel alignment on this 944, and it's a little bit of a fight. It's a lot of work doing it this way, but like I said before, sometimes you don't have much of a choice. Unless you know someone good who's going to do it for you, you never really know what you're going to end up with. So anyway, here's what we came up with for our finals. Camber, left front and right front camber are minus -0.5 degree, which is about perfect. Got about a 1/16 of an inch toe in. We got -3 degrees of castor on the left. I didn't measure the castor on the right yet. I gave it a tweak. It was -3 3/4, so it's probably somewhere a little under -3 degrees. So anyway, I had it out and it feels real good. And that's really what the castor kind of does for you. It's got noticeably better turn in now, which is good. On the rear, we really lucked out. The rear is not easy to adjust at all, but we came out with -0.5 degree on the left and -0.5 degree on the right for camber, and I put down 0 because it was actually, I couldn't measure it very well, but because it was less than a 32nd in, so it's like 1/64th in on rear toe, which is about perfect too. So this car is pretty well done alignment wise. I wanted to talk for a minute about the alignment settings. So basically, the way I look at it, you've got like 3 different kinds of settings. Either regular, normal, street, sports type, like we're doing here, racetrack only, and autocross. So they require pretty much 3 different setups. we'll talk about Castor first. So the Castor, more negative will give you better high-speed stability. So it's something you want on a track car. You don't need it on an autocross car because you're never going really fast. You're always turning. And for the street, you want it somewhere around the middle. You could probably dial in a little more than this for high-speed tracks like for Virginia International Raceway and stuff like that. Tow, generally the factory says they want 0, but something like a 1/16 or less in the front and rear is good for the street. And camber, you don't want a lot of negative camber on the street because you'll wear out the inside of your front tires or back tires, depending on which. The camber is basically to compensate for the tire squishing over in a hard turn. So basically you're kind of moving the tire patch in a more vertical direction. So the more negative camber you have in it, the straighter it gets. If you had 0 camber angle, the tire would squish towards positive camber in a hard turn. If you put a degree of negative camber in it and you push it really hard in the turn, it'll effectively come up to about 0. And if you're going really fast and putting a lot of G loads into the car, then you need a little more negative camber. And tow is, tow's good for the street, like we said, 0 to a 1/16 inch, something like that. For the track, you probably don't want that much tow. 0 is probably better. For autocross, you actually want tow out because you want the car to turn. And if you just try it on your car, you would notice that if you tow it out like a 1/16 of an inch or so, instantly you'll get this much better turn in. Like when you crank the wheel hard, the nose of the car will go right with that tire. So that's basically what we've been going for here, this kind of setup. So this is basically a street setup. Negative half a degree of camber, 1/16 inch tow, somewhere around 3 degrees Castor, minus Castor, and camber in the rears, minus half a degree, and very, 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 it's not really 0, it's actually a hair towed in. And that's it. Now we got our tires on it. All we need to get is that big brake upgrade so the thing will stop like as well as it goes.